Welcome back. In the previous video, we implemented an aiming mechanic and it snaps to the aimed position. So in this video, we're going to go ahead and make this a little bit more of a smooth transition. Now, before we get started, I would like to point out that there's a few variables I'd like to tweak. For one, I feel like we're a little bit far away from our character and I'd kind of like to be a little closer. So I'm going to go ahead and change our spring arm length. Now, our socket offset has us over by 50 in the Y direction and up by 50 in the Z, but I'd like to be a little bit higher. So we're going to tweak that. And then finally, our zoomed in position is not quite zoomed in enough for me. So let's go back into our code. And here in the constructor for our shooter character, we can change these a bit. I'm going to change our camera boom target arm length to about 180, maybe 200. Let's go with 180 for now. And for socket offset for the Z, I'm going to pull this up a little bit more. I'm going to put this to, say, 70. And in our member initializer list here, I'm going to go ahead and change our camera zoomed field of view. Instead of 60, I'm going to go with about 35. Let's compile this and see how it looks. Okay, hitting play. You'll see already we're closer and we're up a little more. So let's go ahead and zoom in, and that's a lot better. See how we're zooming quite a bit and our character is just on the edge of the screen. So we can still see her and fire, but we're zoomed in quite a bit more. So this looks good. It also distracts us from the fact that we're not using turn-in-place animations. We will implement those later on in the course, don't worry. But until then, we're not really thinking about what her feet are doing. So that looks good. So let's get started making this zoom in a little bit more fluid. Back here in shooterCharacter.h, we have a couple of variables here, camera default field of view and camera zoomed field of view. But we're going to be changing the field of view each frame if we're aiming. So we're going to want a value for the current camera field of view. Let's call this, it's a float, and we'll call it camera current, FOV. And so I'm going to give this a comment, and we're going to call this current field of view this frame. Now we're going to want a interp speed for while we're interpolating between these field of view values. This will be a float, and I'm going to call this zoom interp speed. Now this one I do want to give a U property because I want to be able to edit this from the editor. So I'm going to make this one edit anywhere. I'm going to make it blueprint read write, category combat, and of course we need our meta specifier. Allow private access equals true. Now we'll give this one a comment and say interp speed for zooming when aiming. So we can initialize this here in the constructor. So we'll say zoom interp speed. And of course we can tweak this as we're developing, but I'm going to give this a value of 20.f for now. And of course we can initialize the current field of view value. So we're going to say camera current FOV. We can give that a value of 0 by default, but actually we're going to set this in begin play once the camera is valid. And we're going to set that to the default field of view right off the bat. So we can say camera current FOV equals camera default FOV. So it'll start off with the default field of view. So now we have this camera current field of view, and we're going to use this in tick because in tick is where we're going to do our interpolation. So let's go to our tick function. Okay, we're down here in tick. And in tick, all we need to do is make a check to see if we're aiming. So we can say if be aiming. If we're aiming, then we're going to do something. And if we're not aiming, we're going to do something else. So I'll comment this and say aiming button pressed. Now we're going to interpolate. Interpolation allows us to take a current value and a target value and smoothly transition towards that target value. And we're going to use our camera current FOV variable to update each frame. So we're going to say camera current FOV and set that equal to our interpolated value. And we're going to use fmath. Fmath is a static library with all kinds of math functions, including one called finterp2. And this interpolates float values. It takes a current float value, a target float value. It needs delta time because we're using the delta time in the tick function, and it takes an interp speed. Now, I actually explain more about how Unreal Engine's interp2 functions work in a video on my YouTube channel, so I can go ahead and provide a link in the supplemental links for this video. That way you can know a little bit more about how this works internally. So for our current value, we're going to use our camera current FOV. The target value, if we're aiming, our target value is going to be the camera zoomed field of view. So camera zoomed FOV. Next is delta time, which we can just pass in delta time. And finally, we need our interp speed, and we created a variable for that called zoom interp speed. And there we have it. Now, since this goes off screen in my screen, since I have the font so large, I'm going to go ahead and just hit enter to put these parameters in a column here so we can see them all. So we get our camera current field of view value by interpolating from the current value to the target value, which when we're aiming is the zoomed value. The only thing left to do now is to set our follow camera's field of view to the current value. So get follow camera, set field of view. We're going to set it to camera current FOV. Now the code in our else case is going to look almost exactly the same, so we can copy and paste it. The only difference though is instead of interpolating to the zoomed field of view, we're going to interpolate to the default field of view. So our second argument in finterp2 is going to be camera default field of view. Everything else is going to be the same. All we're doing is changing camera current field of view, and we're setting our field of view to the current value. In fact, since one or the other will always be called, we're always going to call this same function set field of view with camera current field of view, regardless of which case. So we don't really need it in both cases. That's redundant. We can just place it here under the if-else statement. And we don't even need it in both cases, since it'll be called anyway after we set the camera current field of view. So we can make this comment a little better. What we're really doing here is setting the current field of view. So we can say set current camera field of view. And in the if be aiming, we can comment this and say interpolate to zoomed FOV. And in the else case, we can say interpolate to default FOV. And then just after, we're getting the follow camera and setting the field of view. This function is pretty self-explanatory, so I don't feel like we need a comment for this line. It's pretty obvious what we're doing. Now, before we test this out, there's one thing we need to do. Since we're setting the field of view here in tick, we don't need to call this function in our aiming button pressed and released functions. So if we go back to aiming button pressed and aiming button released, we can remove these function calls. Aiming button pressed and aiming button released were only ever designed to set be aiming to true or false. So we really shouldn't be doing other things like setting the camera field of view in functions that are not designed for that. That's bad programming practice. We did it while we were sort of prototyping the mechanic. All right, let's compile this. Back in the editor, we'll hit play and we'll zoom in. And we've got a smooth zoom in. Now, depending on your preferences and your game, you may or may not like the speed of this, which is why we made zoom interp speed exposed to blueprints. Here in the combat section in our character, we have, here's aiming, and notice it's grayed out. We can't set that from here because we only want to be able to see it, but that's set from C++. And here's zoom interp speed. Let's say we didn't like how slow it interped, so let's set this to, say, 30 and play test. And that's a little bit faster. For a faster paced game, maybe you like that. So we can leave that at 30. And that's the beauty of exposing variables to blueprints. So let's go ahead and save this. Now that concludes our video. Now as a challenge to you, I'm going to have you go back into the tick function and take a look at this functionality here. We're checking to see if we're aiming, and we're setting the camera field of view, and we're kind of just cluttering up the tick function. So your challenge is to refactor this code and make the tick function look a little bit more tidy. Pause the video, and when we come back, we'll go ahead and implement the solution to the challenge. Okay, so we want to refactor the code in the tick function because it's getting cluttered. We can create a function that will take care of all of this behavior. Let's go ahead and create a function in shooterCharacter.h. I'm going to go ahead and stick it in the protected section. I'm going to make it a void function called camera interp zoom. Now recall in tick, when we call finterp2, we have to pass in delta time. So our refactor function needs delta time. So we're going to make float delta time one of its input parameters. Now I'm going to go ahead and allow Visual Studio to give me a default definition for this function. And then I'm going to go into tick and I'm going to copy all of this code from the if statement all the way down to setting the camera field of view. I'm going to copy it and delete it. And I'm going to go to our new function, camera interp zoom, and paste it in here. So camera interp zoom will take care of all this. And then in tick, all we need to do is call camera interp zoom and pass in delta time. Now the tick function is nice and tidy, and all of the camera interp zoom functionality is done in our camera interp zoom function. And all we need is a small little comment saying handle interpolation for zoom when aiming. And now our code looks nice and neat. Okay, now in the next video, we're going to take care of the animation pose when we're aiming, because when we zoom in and aim, the character doesn't actually do anything. She just stays in the same position, but we want her to animate so it looks like she's aiming, like holding the weapon up to her eye, and she's looking into the aiming device. So we'll continue with that in the next video.